Hi, my name is Peter Thompson, and my partner is Ray Altman, and this is our capstone project, Perplexing Dawn. In this presentation, I'm going to first go over some of the background of our project and the process we went through in creating it, and then in the second half of the presentation, Ray is going to show off a demo of our project in its current state. So our project is a video game about a little robot that goes around a spaceship and fixes it up. It is a puzzle platformer, kind of in the same vein as Portal. So your goal is to go from level to level to level until you reach the end. And in each level, there will be some puzzles that you have to solve and some platforming challenges that you have to get through. Each level is made up of some components which are important for understanding how the game works. First off, you have your robot, which is your player character that you control. And then each level is divided up into rooms. Each room has objects in it that the robot can interact with in some way. And some of the most important objects in the game are the terminals, which we'll get into in more detail later on. So then why are we doing this project for our capstone? Well, myself and then a friend named Tim, we started working on this project at the end of 2023. We quickly realized, however, that it was going to take a long time, that there's a lot to making a video game. And so we proposed to do it as a capstone project, and that was accepted. And so then for our capstone, Ray and I have been kind of working on the systems and mechanics that underlie the game. By systems, I mean things like the physics system or the rendering system. And then for mechanics, I mean things that the player can do in the game, like move around, or carry objects and things like that. At the same time, we've also been motivated by getting to kind of tell a story and develop a game world and kind of all these more creative aspects of the game. And ultimately, we want to tell a story that explores themes like artificial intelligence and the good and the bad in that. The good's going to be represented by our protagonist, our little robot character here, and then we'll also have a mysterious bad guy in the background that represents kind of the bad artificial intelligence. Okay, and then moving on to our business objectives. Our first objective is to create a complete game. Our goal is to be able to sell this on Steam or some other platform like that eventually. And so we need a game that has all the things that everyone would expect from a game, even if those things aren't necessarily core to kind of the central idea of the game. We do want to include those. So that includes like a main menu and camera controls and things like that. We also want our game to be cohesive. So we want all of the parts to work together. And so to that end, we've added a lot of managers and other systems that make sure all of the parts play nice together. Next, we want our game to be enjoyable, of course. One of the main reasons people play video games is to have a good time. And so we've kind of implemented some mechanics that we think are going to be really fun for people to play around with, such as being able to flip gravity and also freeze this goo-like substance that we have in our game. And you'll get to see both those things in the demo. We also want our game to be accessible to as many players as possible. And so towards this end, we have options in the settings menu to change your control layout or to change some of the audio and visual settings to make the game more accessible. And then we've also designed our mechanics around this idea so that they're not too punishing. So for example, the death and respawn mechanic is pretty forgiving. And then our last objective is to make an immersive game. We think if a game is immersive, that really helps it to be more engaging, for the players to find it more enjoyable, and also to be more impacted by the story. And so toward that end, we've tried to make the physics of our game feel more realistic, and also we've worked a lot on the lighting system, so it's more engrossing. Okay, now moving on to features. This is the list of features that we were aiming to complete for version 1.0, which was the winter term, and then version 2.0, which is this spring term. We weren't able to get to quite all of the features in version 2.0. In particular, we did not get to these 4 highlighted features here. However, these 4 features are things that we feel like it might be better to do later on in our project. So we're going to continue working on this project after the end of Capstone. And we feel like these 4 features, it might be better to work on after we've started developing some more levels and we know a little bit more the direction that we want to take the game in. So we haven't completed these features for version 2.0. However, we have kind of taken our original idea for terminals and split that into 2 different ideas, both having like a menu-based or a button terminal, and then a command line terminal. And so then this is our final set of features that we've completed for the Capstone project. Now moving on to testing. Testing video games is quite a challenge because there's lots of systems and each system has a lot of possible states. For example, if you just think about the position of the robot, there's almost an infinite number of positions that the robot can be in, and it's impossible to test all of those positions to make sure none of them cause a bug. The solution to this is to do a lot of play testing, basically to move the robot around, do things that you think might break the game. And then when you find an issue, you take a video of it or you make it reproducible in some other way so that you can find the root cause. We do also have a set of formalized tests for a few features, which you can see here. For the features that have been completed, we've been through these tests to make sure everything works as expected, and it does. There are a few features that we haven't completed yet, though, so we haven't been through those tests yet, of course. So, for example, in the terminals, you can't yet view data logs, so we haven't tried that out yet. And from the menus, you can't save or load games, so none of those tests have been performed yet. But for everything that's been completed, the tests all pass, so that's good. That said, our main method of testing has been play testing, just to try to catch as many things that we might not have thought of as possible. And so, yeah, we've mostly focused on play testing. This is our division of labor for this term. So we both did the documentation, and then since then, Ray has been kind of focusing more on the UI elements of the game, including the terminal interfaces, and then the 3 types of menus. And then I've been focusing more on kind of the physics aspects of the game. So being able to carry objects and move around and changing gravity and things like that. And then finally on to tools and technologies. We use 4 different tools. Godot, which is a game engine, Visual Studio Code for editing code, Blender for 3D modeling, and Microsoft Loop for project planning. Godot is a game engine. It is open source, which is one of the primary reasons we chose it. And it has a lot of great features. Here you can see the GUI editor and some of the parts of that editor. You have the scene tree on the left, below that the file system. At the top middle, we have the 2D and 3D view into the game world. Below that, we have the output. And then on the right side, we have the inspector for changing some properties. No game engine would be complete without the ability to script and add behavior to objects through scripting. Godot officially supports 3 scripting languages, GDScript, C#, and C++. GDScript is built for Godot, and because of that, and also because of all of the tutorials that are available for GDScript, we use that for most of our project. We did use C++ for some sections that needed to be more performant. When using GDScript, you can use the built-in script editor, which you can see here on the left. But for using C++, or if you wanted to use C#, then you're better off using an external editor, and for that purpose, we use Visual Studio Code. We also use Visual Studio Code for its other features, such as Copilot, Vim controls, and its better Git integration. Our third tool we used was Blender, which is some great software for 3D modeling. It's open source. Primarily, Tim used Blender for creating all of the 3D models in our game, and he did a great job, and you'll get to see those in our demo, which Ray is going to go through in just a second. And then our last tool that we used was Microsoft Loop, and we use Microsoft Loop for project planning and also for collaborating on different ideas surrounding design and implementation and things like that. Okay, so now I'm going to pass it off to Ray, who's going to show you a demo of our game.
Okay, so let's get into it. This is our first feature. Our first feature is going to be our main menu. As we go into our main menu, we'll be able to see the different parts. Exit works. Trust me, I'm not going to click it right now just for sanity, for time reasons. So let's get into settings. As you can see here, I have the volume down just so this doesn't override my voice. But if we go up, you can hear that we have copyrighted music 101. As you go over here, you can hear I can turn the music down through a master. I can turn it down through the music. And then the sound effects doesn't affect. The sound effects will be able to adjust to different sound effects throughout the game when we start implementing those, but for right now it's on its own sound bus, and yeah, and we don't need to really worry about that right now. Graphics, so let's go through it. We have windowed, we have borderless, and we have the full screen. Let's go to the windowed. We also have the different resolutions that our game can run at. Right there. And for the rest of the presentation, we're going to go in through the full screen. These are the different ways you can rebind controls. I could rebind it to shift, I could rebind to space, but I can't rebind it to A because that's a duplicate key and it's going to reject me for that. These are for all the different controls that we have. This is kind of exploded versus what it originally was, and let's get started into the game. So here we are in the game, and we're going to start with our first feature, which is jumping. As we go through, we can look at this. Lights on. That's probably important. We'll keep that in mind. As we go up, you can see that we have our first one. This is a command line terminal. We can use these for different kinds of puzzles versus platformer. This is more for like a knowledge base. If we go in here, we also see that we don't do any kind of text sanitization. So we can enter in something like that. And as you can see, nothing really, we don't have a database, but also nothing really happens because it gives us a warning for what went wrong, so you can see what you did, how to affect it, and how to fix that. So let's go through here. Oh, there we go. And get out of that terminal. We'll go back over here. And this is our other feature. These are respawn points. I probably won't be able to show you all this off too much because I don't really plan on dying too much during this presentation. This is goop and or liquid as we started off with. You should just be able to jump right over it. And okay, so as I was saying, we'll probably die plenty, so you guys will see the respawn points as we go. As you can see over here, we have a frozen door, so we'll have to figure out how to get past that. Let's go forward and let's have a look around over here, see if we can get our knowledge checkpoint. Click that. As you can see, we have a box. This is one of our other features, the ability to pick up and put down objects. As we go through, we can pick up, put them down, just so we can navigate our way around the environment, do puzzles that involve dragging, dropping boxes, as we see. We can go forward. All the art's done by our art author. I won't say his name, but he's amazing. Oh, hey, buddy. Let's move over to there. Nope, no. Come on. Yeah. Okay, this is our second one. This is a command line terminal. This is dynamically loaded with all the mechanics that are in the room, making it easy to implement to each level that we want to put this in. It automatically grabs all of the states it could be in, and it allows us to switch between the two of them. Right now it's in stopped, so I'm going to put it into running, and we want to quit. And you can look back, and we can see that it's like this. Whoop. We have this. And then we're going to cha-cha real fast. Cha-cha 1, 2, and we made the cycle. So we're going to go up here, and there's another respawn point. We'll go down here, and I'm going to show you off our new feature. So we did implement death in this game. As you saw earlier, we do death by liquid, death by crushing, and this is actually a kill zone that kills you as you go down, one of the other features. Now we're going to do platform. Oh, I thought I wasn't going to make that. There we go. Okay. And then we'll go over here. I think this upcoming feature is actually one of the cooler features that we implemented into the game. It's actually probably the most visually impressive, and that's the button. And no, I mean, what happens when you hit the button is we have the gravity flip. We implemented this because we wanted to be able to create new puzzles, create new ways that we can interact with the environment, that a player can, and have to think about the world around them. Go through here, hit another button. As you can see, we're implementing a very basic maze, but in the future, you know, a little creativity, who knows what we'll come up with. And we're back to here. This is the room. So this is where you're going to be able to see that we have everything divided into separate rooms as we go through. As you can see, as we go over here, you'll be able to see the gravity flip as soon as we leave the room. And we're out of the room. And that allows us to separate everything and have it all manageable. Go down here, hit the respawn point, hit this. These are previous. knowledge checkpoint. And we're here. Caution, high temperature goo means death for you. Huh. I don't really know what that means, but let's go back over here and look. We have, well, all right, so we can talk about this. This is our interaction manager. It takes the object that is the closest to you and allows you to interact with it. So if I'm closest to the green, I'll let me interact with that. If I'm closest to the blue, I interact with that. And if I'm closest to the red, it interacts with that. We go over here, high temperature. Okay, well, that's probably important. High temperature glue. Goo means death for you. So that means probably that low temperature is good. So let's go ahead, low temperature. Well, failed. Let's do temperature low. There we go. We go ahead, go out and look. And this is our next feature. This is frozen liquids. Oh, look, it's my little spot. Frozen liquids was something we wanted to implement into the game. As you can see, we have it right here. Allows us to interact with it, jump on it, and it stops it from actually being able to kill us as we go through. We go over here. I'm going to hit this respawn point before I get too much further, just in case. We'll go back here. We can use our previous knowledge checkpoint. So, no, lights. Temperature 5. Exit. As you can see, that does actually affect the liquid. The liquid is now in this state, but I don't want to touch it because I've learned that that kills me. So let's do temperature low. And we can exit. And there we go. And we'll be able to actually get through. And we're coming up on the last thing. Huge part of the game, I would say. Let's go ahead and look in here, and we got this. It's kind of dark in here, but we have another switch. It probably just affects gravity, but let's go ahead and... Oh. Well, that's Perplexing Dawn. Thank you.